Welcome to this video about using SQL to query data on Hadoop. I'm Cynthia Saracco from IBM. Earlier in this video series, I showed you how to create and populate SQL tables on Hadoop. Now I'm going to focus on data retrieval operations. We'll explore the breadth of query support available for SQL implementations on Hadoop and also discuss some query performance considerations. Please note that specific SQL examples in this video are based on Big SQL from IBM, a technology that I'm quite familiar with. But I also cover basic concepts that apply to other implementations. When evaluating SQL implementations on Hadoop, it's important to understand the breadth of SQL capabilities that are supported. I've highlighted many aspects that SQL professionals have come to expect and use every day. And while I don't have time to describe them in detail here, I just want to note that rich support for various types of joins, subqueries, built-in functions, and customizable modules are among some of the more advanced aspects of SQL worth examining with any implementation. That's particularly important if you hope to use SQL tools developed for popular relational systems against data managed by Hadoop. If you saw my earlier video on introducing SQL, this query will look familiar to you. It's an example of a query that a SQL programmer might run against any commercial relational database. It includes joins, subqueries, projections, restrictions, and other common SQL operations. Let's see how someone might express that same query against Big SQL, a SQL engine for Hadoop. The original query written for a relational database is on the left, and the query for Hadoop is on the right. Can you spot the differences? Let me make it easy on you. There is no difference, and that's the point, because what many firms really want is the ability to use standard SQL to query their data, regardless of whether that data is managed by a relational database system or a Hadoop-based technology. Before I wrap up, I want to mention another topic that often comes up when programmers talk about queries, and that's performance. Everyone wants great runtime performance, but achieving that can sometimes be challenging. While it's difficult to generalize about this topic, I've tried to outline a few broad considerations here. First, if you're writing your own queries, be specific. Retrieve only the data that you really need and exploit the query engine's ability to filter data on your behalf. Don't retrieve lots of extraneous data and rely on application logic to discard irrelevant information. Next, follow the best practices guidelines for whatever SQL engine you're using. These can vary from one offering to the next, but I've outlined some common areas here. They include making sure that you have sufficient system resources available to run the kind of workload that you have. Understand the different Hadoop storage options available to you, and choose one that's well suited to your application's needs. If your implementation uses a cost-based query optimizer, make sure that statistics about your data are current. And if you experience poor runtime performance for some queries, use available system tools to investigate what's going on. I hope you found this short video to be useful. If you want to see more query examples, I've included a link to some Big SQL tutorials here, and you'll find plenty more for other implementations online too. Thanks for watching.